Hello and welcome back to our continued adventures on the Let's Defend platform. Today we are attempting to tackle the compromised ICS device challenge. If I remember correctly, this is listed as hard. Backstory. Critical water treatment plant has recently experienced unusual behavior in its control systems. The plant's PLC, or programmable logic controller, responsible for managing the water pumps and filtration systems, and is suspected of being compromised. Your team has been called in to investigate and identify the root cause of the anomaly, investigate the logs, and identify the sequence of events that led to the system's compromise, determine the type of attack and the attacker's actions. And so we're given a Linux VM with a folder on the desktop called challenge file, and inside there is an ICS-artifacts.7zip. So off screen, I have gone and collected the 7-zip, extracted it out to my Windows box, and right now they give you a .log file, which is just something you can open up in like Notepad++, and a PCAP file. So I've got that open in Wireshark, and I've got it being processed through Network Miner right now. So let's take a look at some of the questions. While investigating the logs, you notice an unusual access pattern. What is the table ID value of the program that was running when the attacker gained access to the system? You need to determine the entry point of the attack. What is the public IP address and port number of the service running on the PLC? What is the IP address of the attacker? Logs reveal several failed login attempts. What username and password did the attacker use to finally gain access to the account controlling the PLC? What was the user agent used by the attacker when they were attempting a brute force attack? The attacker manipulated the industrial protocol to control the pumps and switches. What is this industrial protocol called? What port number does this protocol typically use? After gaining access, the attacker targeted a specific URL to manipulate the running program. What was the full URL that was used? During the attack, the intruder turned the water pump on and off multiple times before leaving it on. When did they first turn the pump on? And what was the final state of the pump switch and water pump in the system after the attacker left? Answer format. Pump dash state, or pump switch dash state underscore water pump dash state. 0 underscore 1 as an example. Okay, so we're looking for some sort of reference to table ID. All right. So give me 1 second. Let's get a couple of things here dumped in. I'm not entirely prepped and ready to go, but that's all on me. Okay, so if we bring this over, this is the logs. Okay, I misspoke. I guess it was logs.txt, not a .logs file, but development device looks like this was available running on 172.31.26.207 port 8080. Isn't that T-Mobile address? I think they own the 172 dot something range. So basically I'm just jumping over to interesting. I have been blocked. All right, hang on 1 second. I think I know what's up. Oh, never mind. I was blocked because this is a private address, so it must be 172.32 is starting with their particular IP range that T-Mobile owns. Okay. So, but that doesn't really tell us anything anyways. So we're looking for an aspect with table ID right off the bat, lines 8 and 9. I'm seeing 302s where we're doing a reload dash program, question mark table underscore ID equals 1. So let's just do this. We're looking for table ID, find, and show me the table IDs. We got 1, 1, 1, 1 down to lines 159 and 160. And then we get down to 208 and we hit 16. So let's use the test to take the test. This should be a single digit per the layout of the answer key because it's just a single asterisk. And we get 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Looks like this is like monitor update, port 50. No, it's MB. Okay. So it looks like we got a thing between table ID of 0 or 1. So we're looking for an unusual access pattern. Yeah, because it did point dash update and then table ID 1. They just did it with 0, and we're still working our way down. Because 302 would be redirect, so I'm just going to take a guess at 1. Okay, and according to this, that was actually correct. So the question is, how, well, I mean, that's basically the start of the logs. Reload dash program table ID 1. And that's right off the bat. And this is saying, okay, what is the public IP address and port number running? Well, it's kind of interesting because the first couple of lines running on all addresses 0.0.0.0, and then we get 127.0.0.1 port 8080, which is local loopback, and then 172.31.26.207, but that's not public. That's private, because that's why I honked off Talos. So we're just going to try the 172.31.26.207. And we're just going to do like maybe a slight suspension of disbelief. No, okay. Well, now that's interesting. So that is most assuredly not it. Okay, so how else do we want to sit there and try to approach this so it's not obviously? And if I pull up Wireshark, actually, we're fairly certain that we can confirm that one, it is port 8080 without too much of a hassle in regards to this. So what if we look in logs for anything else that would mention 8080? And the only thing we get is the local loop back and then the actual 172.31.26.207 on port 8080. Outside of that, we see a bunch of 197.32, 128.58. So here's the question. Can we run that in Talos? Maybe, possibly, kind of slowly. Oh, I'm sure it's probably me as I'm routing traffic elsewhere. This is from Egypt with a poor IP or center IP. Listed on Spam House. So I'm willing to bet that's probably the IP address of the attacker, not. No. Okay. Do I have it reversed? No. Well, bugger all. So we're looking for something 2 octets, 2 digits, 3 digits, 2 digits, 3. Just a lot further down in the log for the attacker. So how about 38, 180, 17. Wait, no, that wouldn't be it either, would it? Because it's supposed to, no, it's a 3 octet down at the bottom. Yeah, that was it. Transition this over. So the 38, 180, 17. So is that known? Netherlands. PSI net. Without much of anything there. Okay, well. Network miner is almost done. So Okay, so what if let's take a look at the traffic back and forth in regards to HTTP traffic in the Wireshark. And basically what we end up seeing is our private internal talking with 197.32. And that's all over port 8080. And it's just basically back and forth between those two for a while. I'm assuming at some aspect we end up seeing the introduction of the other. Yeah, right in here. Talking back and forth over port 80. And yet they're talking to 172.31.26.207 on port 8080. So somebody explain that one to me, because we tried that. And that should be 2 digits, 3 digits, 3 digits, 2 digits. Which would be the 172.31. It's got to be port 8080 because this one here is from the attacker IP address to the 172.31.26.207 on port 8080 as the destination port. Did I screw up typing that or something? But yeah, it should be colon. Okay, so their thing is check the host traffic. Fine. I guess that, yeah, would make sense. It's probably routing. Yep. There's our refer, and there's the host. 18.194.239.42. Again, port 8080. I guess that makes sense considering the fact that it's going to be dependent as to where we're actually performing the network sniffing, as opposed to anything else. Did that come through or not? Oh, no, it would not have, because I don't have the follow the TCP stream up. Okay. So that's effectively what it was. So I limited it down to follow the stream, any of the particular ones where we have the 172.31 address in there. And when we go and take a look, this is what we're presented with. So we get the host, and that's where we pulled it from. We got user agent, the rest of that stuff too. So didn't they want to know the attacker's user agent? Something did. Something. No, we've got to find the. We'll have to find the brute force. They probably changed a tool. Okay, so the question is, can we find the brute force? So let's see if we can find the where we first get the introduction of that IP address. Maybe? It's a huge... Oh, wasn't there a question? I know we're going out of order, but if you notice in there, the protocol MODBUS TCP, that is, I believe that is one of the actual answers that we're looking for. What is it? Yeah, okay, so MODBUS. What port does this protocol typically use? Do we get a, I mean, we get that it's TCP, but looks like the answer is going to be 502, at least from the PCAP. I mean, like, okay, how'd you figure that one out? So I think out of all the challenges I've done thus far, nothing has involved any sort of ICS. So it's not uncommon to see protocols like TCP, DNS, ARP, UDP, stuff along those lines. That would all be reasonably normal. Oh, what is it? SMB, small server message block, basically Windows file transferring. So Modbus is the first thing that stands out. Okay, so how do we get the 502? So taking a look at any of the examples of Modbus/TCP and going back and forth, the consistence is, okay, so this one is going local server or local loopback is 502. While the destinators, this one, the server port's 57,551. Granted, it's the same thing through here, but effectively, we also had 3 digits, or 3 asterisks for the answer key. So, 502. So it's like, I wonder, can I apply a filter as selected? So protocol is Modbus/TCP. I know we're kind of dipping away. And I did not have Wireshark up to show that. Oh, we got plenty of stuff here. So protocol Modbus/TCP. And basically, I'm just looking underneath the transmission control protocol section, looking at source port and destination port. And I was hoping to see something else besides the 127 address in there, and I don't. But effectively, that's how we end up getting the 502, as it's the only 3-digit port that's there. Now, obviously, the other aspect would be Google's your friend, and we could potentially just search. So let's take a look as the IP source being our attacker. And I mean, we got a metric ton of traffic. And we're looking for anything to talk about. Okay, here's our post login right here. So if we follow that HTTP stream, and let's see. Yeah, that one's not going to show up there, but if there we go. That fixes that. Okay, now we transition that over. So now we're following it. So it looks like they did the username of all4m and the password of C%. Oh, there might be some URL encoding on that one. But what we were looking for was user agent. And up at the top, we get python-requests/2.32.2. And so I'm expecting that is going to be our answer in relation to that. So let me get all the rest of the stuff out of the way. We'll transition back. And am I going to fail or am I going to win? We're going to win. Okay. What do we have left then? We need to find the username and password. So I don't suppose we would actually log out and have it actually just written straight in the logs. I don't know. That would be something to think on. So what are they trying to hit when they're doing this? /login. So they're doing a post/login. So what if we just look for login in the logs? Okay, that's our 19732. That's not our attacker. That's not our attacker. That's not our attacker. That's not our attacker, although we're seeing... Oh, gets. Not posts. We do. Here's our posts. Nope. We are not going to luck out in regards to that. Okay, that's fine. So did they end up getting an error message in when they post that? They get a connection closed. All right, so we are just going to have to basically, looks like from here on in, take a whack at all this. And so the question is, did Network Miner ever finish? Or did I basically just waste the CPU cycles for nothing? Oh, it finished. So I should probably show that too. And so it looks like they ran through a lot. They did that all for M. Or A1. Is it A1L4M? Or all for M? And then it looks like they switched over to an open PLC. And we start getting the session. I would love to know as to which one of these potentially worked. So, I mean, we get the valid login unknown for all that stuff. But are we doing this? Yeah, we're doing this by at time. And we start getting session cookies. Wait, 18194, let me guess. If Network Miner had actually finished in time, yeah, we would have gotten the, without having to dig through that, but whatever, that's fine. So apparently we get Open PLC and Breaking Bad, potentially. Only because of the fact I'm looking at the first login, and it seems like 1945-40 UTC, and then immediately we start getting actual session cookies. So I suppose what we could do is let's get rid of that. And let's go Breaking Bad as a string. And here's the attacker reaching out TCP. We get a 200. So can we just follow the TCP stream, and can you tell me as to whether or not if I got lucky with that? Something to say, hey, successful login? Nope, that was bad credentials. Welcome to OpenPLC. Bad credentials, try again. Okay, so let's do this. And let's make this huge, because I don't know what the successful is it going to say good credentials? Welcome to enter your credentials to continue. We get a graphic. Bad credentials, graphic. Bad credentials. Bad credentials. Graphic. Bad credentials. Bad credentials. Bad credentials. Bad credentials, graphic. Bad credentials. Graphic. Bad credentials. Graphic. Bad credentials, graphic. Bad credentials. graphic, bad credentials, 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 graphic. Oh wait, no, not graphic. This is ABC123. Bad. Open PLC Nicole. Bad. Daniel. Bad. Baby girl. Bad. Monkey. Bad. Lovely. Bad. Jessica. Why Jessica? I guess maybe if they were a Rick and Morty fan or something. 654321. Bad credentials. Michael. Bad credentials. Z1 Charlie at MP10N. Bad credentials. AACBAF $, pound, at, asterisk. Bad credentials. That in reverse. Bad credentials. HNACY25J. Where are they pulling some of these things? Antwerp. Guam. Bad credentials. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Bad. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bad. Password. Bad. I love you. Bad. Princess. Ooh. Bad. 1, 2, 3, 4, 5, 6, 7. Bad. Rock You. Famous for the Rock You password list. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 8. No 9. Bad credentials. ABC123. Bad. Nicole. Wait, are we looping back around now or no? We might be looping back around. Because that's Daniel again. I can't imagine that they would try it. Baby girl. Bad. Okay, outside of open. Open PLC. What else did we end up getting? Well, it's either that. No, there's ones in here that I haven't observed yet. Monkey. Although it seems like we're just rotating back through, because there's Jessica again. I mean, unless it's... Because I see items in there for like admin, everything else like that. Michael, yet again. Monitor update. So I have to imagine it's going to be roughly about that last password that's going to be checked. So basically I am just shifting through this to see if I can find okay, dashboard. So it looks like they managed to get in with that one. Bad credentials. Okay, can we follow the TCP stream for this one? See if we can follow that back and see if we can get a idea. No, because that just takes us straight to the dashboard. Okay, what about the stream directly before this one? Okay, let me... So I'm digging through all that stuff. Take that out of the way. And so I found this. So we get a 302 found. Open PLC, and the password is Breaking Bad, which I could have swore we tried, or did I not try? I didn't, apparently did not try. But, so what we end up seeing is, okay, we got our server, we're posting to login, we're doing username open PLC and password equals Breaking Bad, we're getting a 302 found, and then we're getting apparently redirected to /dashboard as the texts that are in there. It's just like, okay, we're redirecting. You'll be redirected automatically to the target URL /dashboard. If not, click the link. So we're gonna just copy and paste this. And we put it in the format that they want. So username, password. Crap, I thought I stuck it in there and something was wrong. Apparently not. Okay. So let's see. During the attack, the intruder turned the water pump on and off multiple times before leaving it on. When did they first turn the water pump on? Okay, so let's take that. And can we do just a simple search in the logs for water pump? It's at the very end of the log file. So they want to know, okay, monitoring. And that's the only time those things actually show up. So, okay, let me pull that up. So I'm looking at the logs.txt, and at the very bottom of the file, I just did a search for water pump. But if we take a look, we see pump switch, and we see water pump, location, QX0.0 or 0.0, type Boolean, and then a bunch of opening database. I mean, is it the fact that they're both at 0 so that they would both be off? No. So that's not really going to help us a whole heck of a lot. Well, okay, you search for water pump. What if we just do the search for pump switch? We get that, and that is the only time that it's actually listed in here, which makes me think that we're going to be looking for water pump in Wireshark. Okay. So let's go back to Wireshark. Let's get rid of the stream. Filtering that we did. Let's go ahead and pick a packet, and let's see what happens if we just put in water pump. Okay, apparently we found something. What did we find? Okay, so it does show up. So it looks like it's off by default. And so we need to find the first instance of the attacker turning the water pump on. So that's not it. That's not it. Okay, let's take out our oops. All right, so we're going to take out the 197.32.28. Now find me water pump, and we'll probably find the attacker's IP address to make this a little bit easier. And I realize I don't have that translated through. Okay. So effectively I've created a filter. No packets contained a string. And it's just set. Really? I mean, we should get something for the attacker's IP address. I mean, at least, dear God, I hope so. No packet contained that string in display. Well, crap. Can we do a status? Does that give us anything? Where it might be potentially used? Yeah, in just about every one. That's not really helpful. remember my... I want to put two displays together, but I want to make it so that it's OR. So is it just as simple instead of and just do OR? Or is it lowercase? I mean, realistically, I could just sit there and take it, so that would be... I thought IP destination wasn't supposed to be. Okay, you know what? Let's find our attacker IP again. Or, screw this, I'm just going to go back and lift it off of what we were working with. So the 38, 180, 17, 118. Oh, what is it? IP SRC equals. Or IP dot, was it DST or? Yeah, DST. All right, so I want you to only give me sections where it's either or. So it should limit the amount we end up seeing. About 20% of what we've got. And then through here, if we do a search for water pump, no packet contained water pump. Oh. Oh. We kind of missed one. There, we kind of jumped ahead. I mean, not that that's frowned upon or anything. After gaining access, the attacker targeted a specific URL to manipulate the running program. What was the full URL they used? So it's going to be our non-private IP, port 8080 slash something dash something question mark. I think I know what this is. So if we go digging through, taking a look at the info sections, and I just realized that the mouse isn't showing up here, so for whatever reason, it's supposed to be doing capturing cursive. There it is. So if we take a look in the info sections, we'll see that after they get logged in, we see a get monitor dash update MB port 502, which looks to see about what they cover. So if I follow this, will I get the full? So it looks like they're doing monitoring there. So it looks like it's going to be, I'm going to just cut and paste this. And we're just going to have to put these two together. So this eventually turns into HTTP 18.194.239.42:8080/monitor-update $MB_port equals 502. I think. I guess there's one way to find out. Oh yeah. Okay, well we have state. So I don't suppose I could go back to the log file and I realize, yes, I'm not sharing, I am just taking a look to see as to where state shows up. And the logs.txt, there's only one time that state shows up. It's line 245, channel state change opening. So that doesn't help a whole lot. And then effectively all we get from there is, like if we actually look at the logs, they actually seem like semi-crappy logs. You would think that it would be a important enough thing that, hey, water pump turned on. But I'm not seeing that at all. Okay, so it's going to be effectively nuts to that. So if we, oh, please tell me that this remembers. Yes, it does. What we had. So let's go back. So we've got our IP source as being the attacker, or IP destination being the attacker. And we're going to try looking for state. Already state change. All right, let me take this all the way to the top, and we'll try taking a look for state. Where's state on this? Process. That's it. All we're just going to end up with is just rec dot onReady state change equals process rec change. This seems to be about the only thing that we're running into here. Because we're trying to find anything in regards to. Okay, what if we, instead of water pump, what if we just look for pump? So we'll take it back to the very first section. Find me pump. Status running. Okay, so now we need like a timestamp for this, because it looks like this is when they turn it on. When did they first turn the pump on? So this is from the attacker starting at the very top. So hopefully we're going to have do we have some relative timestamp? Timestamps. I was hoping more for something a little bit better than that. Wait, here's our date. We got us a date. Then I'm assuming I'm not really going to rely on the log file anymore. So GNT should be the same as that. So we've got June 14th, 2024, 19:45:41 GMT. Maybe. Except that's not going to work because we need to have a point something 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 something. Okay, so let's try the UTC arrival time then as our value, because that seems to fit to an extent, and that gives us everything in. Well, I'm hoping that that's what they want is UTC. They don't typically specify that here. So it looks like they're using year dash month dash day and then the time. Okay, so Wireshark gave us June 14th, 2024, 19:45:41.30452800. So now we need to try to put that into a format that this thing wants. So that's going to be 2024/06/14 space 1, 2, 3, 4, 5, 6. So I think we're just cutting off the 3 ending zeros from the timestamp that they have. So that should theoretically give us 2024-06-14 space 19:41:41.304528. Or did we send something before that to state, hey, turn the device on? Hmm. See, now that just gets us the dashboard. And of course you can't see because I just have not actually shared out the window. So Wireshark and then our stuff as we run through this. So it looked like that was the PLC. At dashboard. Well, we're not going to get anything. We might want to just save the filter. 38, 180, 17, 118. So what if the pump was already running? They didn't turn it on at that point, so it would be then the first off and then on, right? As I say to the empty room and the void, except for the puppy over on the love sack that's just passed out, sleeping. Program water pump running. Water pump running. So it looks like they turned it off. Pump switch Boolean is false, so it's off. False. False. Come on, turn it back on. Yeah, because all I'm getting from this is that it's just off. 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 It doesn't look like he's turned it, or the attacker's turned it on once. Yeah, it just stays the same. I mean, you would think that there would be a value change in this, especially if they're turning it off and on. All right. Still working on the time, but for the final question, the state of the pump switch and the water pump. The question above denotes during the attack, the intruder turned the water pump on and off multiple times before leaving it on. So I just hazard a guess that the pump switch was 0 or off, and the water pump, kind of spelled out in the question above that it was left on, so 0_1. I'm still trying to work the time. For when it was first turned on. Not having a heck of a lot of success actually correlating the water pump. Because it's basically said that the water pump was turned on and off multiple times. The only thing I'm finding is Boolean values for false, which would make me think that, okay, water pump is off, but not having a whole heck of a lot of luck, so I'm going to keep at it. So yeah, as an added point in regards to pump switch. So basically I'm looking for that the info column's got to be HTTP 1.1 200 OK, and all the searches for pump basically return that inside the value we've got pump switch denotes that basically it's just off. Bool false.png, and it's basically reporting as no or 0.0 all the way effectively through. So I guess what it really means is I need to figure out what the actual name of just the water pump itself as opposed to pump switch. Maybe that would help with this. Well, it was an awful lot of time wasted. So, got it. And here's the answer. I wasn't using the proper formatting for the time. I had periods as opposed to colons. So yes, it was telling me I was close to the correct answer because I just wasn't using colons in the appropriate place. I was using periods. This is why we should probably all have a good bit of coffee before we go through and try tackling this. So I had basically focused on HTTP to run through. I even asked for assistance from Nullwire, because apparently he finished it. And what he was giving me was right back the same aspect. So the aspect of going through and searching the packets. So basically doing the search, so limiting to HTTP would do the same thing here, and then doing a packet search for boolean_true.png will still give us frame 56993, which is set up for the time of June 6, 2024, 1951:54.234789. As long as you use the colons as opposed to the periods in between the 19 and 51, the 51 and 54. So yeah. Oh, good Lord. yes, more coffee. Boy. And then effectively for the last question, I think I went over that. We never see the actual pump switch from off to on. It stays off the entire time. Whereas if we were to watch the bool_true.png, we would see that that would end up being the last one as long as the HTML had it. I had also come up with what I've got highlighted down there on line 7806. Searching in the packet data for water pump, and then basically trying to find the Boolean true values, that it would be wholly focused on that. Although I believe that water pump and pump switch both show up in the request. But this was just trying to, before the Slater, well, actually greatly more elegant solution of the display filter, the null wire had. Which, let me just dump that in there so that way it's a little bit bigger. So, my garbage and his better looking and a lot better stuff. Because I think I ended up getting, I don't know, I think it was double digits still of the available packets to search through, and null wires display filter actually will give you only 1%, so it's even more targeted. So better. And then the other aspect that I wanted to touch base on, I don't think I had it pulled up in regards to the IP address, the actual local host. So let me get Putty out of the way. So here is network miner with the PCAP. This is the 172.31.26.207 machine that we saw in the logs.txt. And if we take a look at the host name fields, we're underneath hosts in network miner. We get the 18.194.239.42. So, hooray on that. And also, if we were to take a look at incoming sessions and break it down for port 8080, we do also see that that is mentioned in there, the 18.194.239.42. So, a couple of different ways to approach this if you wanted to try to pull this stuff together. And then the credentials. Yeah, sorry, I don't remember as to whether or not if I had this stuff actually up and was showing at the time. This is going to have like an hour and a half run time, and realistically, I've been at this for a lot longer. But underneath credentials, the last one that appears to have been tested, which we ended up figuring out was indeed correct, OpenPLC and then Breaking Bad. So, if you could use the tool and it makes things easier, better to go with, go for it. And if you get stuck, don't feel bad about asking for help. I mean, I've got years of experience in this particular aspect, and I needed someone else to sit there and say, effectively, no, you got the right data. You must be putting it in wrong. Yeah. Problem in between computer and chair. Or picnic. Or whatever. Okay, so there we go. That is the compromised ICS device challenge. I'll find a couple of articles, hopefully, that will go through and explain maybe like a quick primer on MODBUS and effectively how ICS is different than IT. It's effectively OT, or operational technology. So computers in manufacturing stations. So think like automated coffee makers, maybe automated packaging machines, things of more of an industrial nature. But typically heavily, this type of stuff is like wastewater treatment plants, stuff like that. So these would be the automated systems that would go through and adjust the amount of chlorine to be added to drinking water, say. And I'll see if I can't find some of the notices that went out, stories that were written about, especially water treatment, being hacked and compromised in the last couple of years. You want to have a pucker factor. That's it right there. So, with all that being said, this has been the Compromised ICS Device Challenge on the Let's Defend platform. And with all that being said, I will see everybody in the next video.